What is aspartate? Aspartate is negatively charged that's synthesized by transformation of oxaloacetate, which is a non-essential amino acid. Aspartate considered acidic amino acid due to extra carboxyl group on their side chain physiological pH around 7.4. It is important for building block for new protein metabolism and neurotransmitters such as TCA cycle, nitrogen metabolism, urea cycle, and nucleotide biosynthesis. What is the sources of aspartate? Aspartate sources come from dietary sources like animal, which is meat and poultry, oysters, and dairy products. In plant-based, aspartate sources rich in avocado, asparagus, and nectarine. In endogenous sources, through transformation process, oxaloacetate receive amino group from glutamate to form aspartate and alpha-ketoglutarate.
Dietary aspartate is mainly present as a part of protein like red meat rather in free form. Protein digestion begins when broken down by chewing and mixed with saliva and continues to the stomach via peristalsis. Real digestion starts in the stomach when HCl denature the protein. The enzyme pepsin hydrolyzes this protein into shorter polypeptide that contain aspartate. However, the major digestion of aspartate occurs in the small intestine. Pancreatic proteins including trypsin and chymotrypsin further hydrolyze polypeptide into oligopeptide and free amino acid. Following this, brush border peptide on the intestinal epithelium surface, then complete digestion, releasing free aspartate. Aspartate absorption primarily takes place in jejunum. Free aspartate is transported across the apical membrane of the site via sodium-dependent amino acid transporter. In addition, DIE and tripeptide containing aspartate are absorbed through the PEPT1 transporter and subsequently hydrolyzed into free amino acid inside the enterocyte. Unlike some amino acids that pass unchanged into circulation, a significant portion of absorbed aspartate is metabolized within the external mucosa. Aspartate participate in a transformation reaction where it donates its amino group to a form of solicitate. This allows enterocyte to use aspartate as an energy source. Aspartate also contributes nitrogen for synthesis of amino acid, nucleotide, and bioactive compound.
The function of intestinal aspartate. The first function is energy metabolism in enterocyte. It is a major energy source for epithelial cell of intestine. It plays an important role in regulating amino acid pool and protein synthesis. For example, aspartate involved in the mTORC1 pathway for intestinal mRNA translation, protein synthesis, and cell growth. The second function is malate aspartate shuttle. Aspartate participate in the process because oxaloacetate cannot be transported directly from the matrix into the intermembrane space of mitochondria. The third function is intestinal cell growth. It alleviates the severity of colitis, maintaining intestinal barrier after injury, and promotes intestinal stem cell proliferation and differentiation to alleviate colony epithelial damage by regulating of mitochondrial metabolism and dynamic. The fourth function is nucleotide biosynthesis. Aspartate as a nitrogen donor in the synthesis of nucleotide by contributing carbon or nitrogen atoms to nucleotide. It involves in purine and pyrimidine biosynthesis. The fifth function is regulation of intestinal metabolism. The first one is regulation of hormone release. For example, it activates metatropic glutamate receptor 5, stimulates NMDAR-mediated neurotransmission by directly acting at the glutamate binding site of NMDAR. Ninth is it involved in nutritional function related to growth, and also it involved in growth performance and inflammation that is associated with the gut microbiota.
We can now clinical significance of aspartate. Aspartate aminotransferase AST.
AST is an enzyme measured in a blood test. When the liver is damaged, AST is released into the blood.
It is found in the liver, heart, muscle, and kidney.
High level of AST indicate hepatitis, cirrhosis, and liver cancer. AST level temporarily increase when deep burns, intense exercise, surgery, and seizures.